Hi, Professor Dipankar. How are you?
Hello.
Morning.
Um, I hope you can hear me well. I'm
Yeah.
on travel actually. I'm in Pune right now.
Oh, nice.
Uh, um,
How's the weather in Pune?
it's in, it's warm,
It's
but
warm.
day is probably not as warm as in Delhi right now. But nights are cooler.
Yeah, for some reason, Delhi is a bit cooler today. I
Yeah.
feel that. Yes.
Hmm. Okay. Um, so, Shiva,
Aditi, do you want to wait for professors? We can wait for, say, 3 more minutes and we can start at 12:05. I think participants are just joining and everybody needs a.
Entirely up to you.
We'll just take 3 more minutes.
Yes.
Yeah.
thank you so much for joining in. Welcome, everyone. We'll just wait for some more participants to join in, and we'll be beginning shortly.
Roshi, I think Shivam just raised a question, maybe raised his hand.
Okay. Shivam, do you want to say something? No. Okay. It's okay. So, Aditi, I think meanwhile we can just walk everyone through the structure of the webinar and then we would be in a position to start.
Oh, I think, yeah. Okay, well, welcome everyone for this career spotlight on data fuel for future pathways. Why we are talking about data today is very interesting because we have two lovely faculty who have done very different things working with data, achieve very different outcomes and objectives out of it, but very intriguing. We have Professor Rintu, who works in data science at Ashoka University, and he's done a lot of data applications in biology as well, very specifically. And we have Professor Dipankar, who is a physicist actually, who's a physics expert, and he has used data in a lot of space related astrophysics related fields. So while astrophysics, he has done application of data in astrophysics, but he has a very well-rounded sort of experience in the field of astrophysics and also connecting that with the wonders of space and the universe. So that's why hence we are going to talk about how data is actually helping both these fields as well, and of course talk more about astrophysics as well, and the future pathways in both the fields of data science and astrophysics. So that's what the webinar is about today. And what we're going to do is we want to begin with something very quickly from you, where we want you to tell us, all the attendees to tell us, why are you here today? What's your motivation to join? What kind of questions are you looking to get answers to? Um, what sort of interests you in the field of data science of astrophysics, if you may. So if you could talk about that, tell us in chat, or if you feel you want to unmute and share, please go ahead, raise your hand, and we'll help you unmute yourselves. So really looking forward to your responses in chat. I'm going to pause here. Neeraj has said that he's asking a question around, would an undergrad in data or biology at Ashoka count as a pre-med track in the US? So that's a very specific question, Neeraj. Thanks for putting that in chat, and we'll be taking that towards the end of the session. But for everyone else, please let us know if you have any specific questions, any sort of ideas about why you're here today, any purpose that you're looking to fulfill. And it'll be great if you can also unmute yourselves and talk. We would love to hear your voice as well. So please let us know. So Neeraj is also asking about science labs at Ashoka. Shashank is asking, are we going to have data modeling with technology as well as biology? Okay, sure, we'll take that up, Shashank. Thanks for putting that in chat. Apart from questions, if you could also sort of tell us anything else you have in mind. Again, what's your motivation to join in today? What would you like to know? Shashank has raised his hand. Shashank, would you like to unmute and talk?
Yeah, go ahead, Shashank. You can unmute yourself.
Thank you, ma'am. Am I audible?
Yes. Thanks, Shashank.
Ma'am, the motivation to join today's webinar is I wanna just like everything in the world currently nowadays is based on data and their collections. Even experts nowadays are accessing data just 50 years, 60 years ago to create a model which is which does not exist nowadays, which does not exist till now. So to building a foundation with the data is very crucial nowadays and future generation for Gen Alpha. So that's what is my motivation to join today's meeting. That's it.
Great. Thank you, Shashank, for sharing that. Any other responses? Anyone else? In case you have any sort of answer to this question, please do put it in chat. So now we'll move on to the next segment of our session, essentially, which is a fireside chat with our faculty. So welcome, faculty. We have Professor Dipankar Bhattacharya, who's a faculty at Ashoka University. He's also been an ex-dean at IUCCAA and an ex-faculty at Raman Research Institute. He's a PhD in physics from IISc and a postdoc from University of California. And his master field is astrophysics. So welcome, Professor Dipankar Bhattacharya. Thanks so much for joining us today.
Thank you.
And we have Professor Rintu Kutum, who's a faculty fellow at Ashoka University. He's also a visiting faculty at IIT Jodhpur. He's done his postdoc fellowship from IIT Delhi and his PhD from CSIR. And he's also an eLife ambassador. So thank you so much, Professor Rintu, for joining us today. A very warm welcome to both of you. Professor Dipankar will be teaching the course on astrophysics, stars, stardust, and us in the Horizons Achievers Program 2025 during summer. And Professor Rintu will be teaching a course on data science, applied data science with ML and AI in the Horizons Achievers Program 2025 during summer. So, professors, a very warm welcome to you. Thanks so much for joining in. I would actually like to invite you for a fireside with me so that we can get we can share a lot of information with our attendees today. And also not just share about the program, but also sort of understand about these fields as well. How we'll do this is I'll be asking you questions one by one, calling you out, and you can take a minute to answer that, and then I'll move on to the next faculty. So, are you ready?
Yes.
Yes, yes.
Great, awesome. So, I'm actually very, very curious. A lot of times, I'm very curious about why people choose the fields they choose, and more so because when you're in school, like when I talk to eighth graders, ninth graders, even high schoolers, people who've not chosen a specific field in 11th, 12th, a lot of times they have like these different ideas that they want to do this, and that idea changes probably 6 months later, right? Like, and that's something even I went through, and I think all of us go through. where we feel that no, maybe I'm interested in design, but no, maybe I want to do like data, or maybe no, I want to sort of study math and do something in that, right? So there's so many career options in today's age, and they're constantly evolving, that I'm often intrigued to understand why somebody chooses a specific field. So I think my question to you, Professor Dipankar, is the first question, which is, if you could talk about your experience, if you could tell us what was your motivation to pursue a career specifically in astrophysics. If you could talk about that, please.
I think, in my opinion, life is full of accidents. I don't think we, on day one, choose what we eventually become. I trained to be a high energy physicist. During my master's, that was the track that I was pursuing. Then there was one summer school which I attended, which was on astrophysics. And this was on a new astrophysics program that was being started in India, which is a joint program by all astronomy institutes. So they held a summer school for master's students. I went there. And it was an eye-opener for me that it is a field which does not restrict yourself to one branch of physics. It is actually a synthesis of all possible branches of physics. And not only that, it has it addresses phenomena in such vast scales, from solar system, which is a tiny scale, to the whole of the universe. So it was very fascinating to me, and particularly because I was very interested in using the knowledge in all branches of physics to solve a problem, rather than specializing into very narrowly in one branch. That was my primary motivation. But the byproduct is that you get to learn about objects, some of which you cannot even imagine. And astronomy gives you that opportunity to encounter such vast universe of objects and phenomena, which is fascinating.
Thank you, Professor. And that's very interesting because, sometimes how life exposes us to this one experience and then our entire life revolves around that. And I think what's very interesting is something that I learned because, I actually didn't even know that astrophysics has applications of all different aspects of physics. It combines all sort of concepts and it actually applies that to figure out what sort of can happen in space. So thank you so much for sharing that. And now I think the same question to you, Professor Rintu. You have a very, very diverse experience in data, while people use data for a lot of things, but you chose to use it in specific fields as well. And I think our students today are asking questions around that. So if you could talk about your journey and tell us your motivation to be in this field.
So one of the things which, as Professor Dipankar actually mentioned, it is very, accidental, all the events that happened and today what I do. And it started since my class 12 actually. So since, class 10 and class 12, I wanted to pursue medicine. And that led to a lot of entrance examinations that I, did, and I could not clear them, then end up in doing biotechnology at the end for my bachelor and master's. And I was always interested in human biology and all those, very much in the medical sciences. During my master's, I did a dissertation in one of CSIR institute, and that actually really changed my trajectory. So today I feel like, a lot of the things what I do data science is post my bachelor and master's in biotechnology, where we did not had any exposure to computing. And during my dissertation, I was blessed to have two mentors. From one person was a, who finished his medical education in MBBS and was doing PhD, and one was doing his he finishes CS degree in MCA or Master of Computer Application. Then he quit the job and then he transitioned into biology. He wanted to do biology and he started doing computational biology. And I was blessed to have those two mentors at that point of time, and they introduced me to the how through computational sciences. and understand human biology more in greater detail. And that actually led to my decision of doing PhD program, and then led to postdoctoral studies. And as I went through those whole processes, fundamentally it is like the problem solving mindset that I had. It is, and that really was fine tuned by both, not only the experimental biology expertise that I had during my bachelor and masters, but because I had the computational science aspects of the health and biology. Today, I very closely work with like AIMS, New Delhi, and we look at the disease conditions like where in our country we are very much far behind in understanding, or the what happens inside a cell. Like as the Professor Dipankar mentioned, like we are looking at the from a physics, the what we see with our naked eye, but what is there inside a cell. So we do more of a like a that resolution of data science within a cell, and why some people take different pathways, why some type 2 diabetes people respond differently than the other one having the same medication, why in Indian we'll see more incidences of those, what is the biology of those, what is the molecular basis of those. And I think those huge amount of data get generated, and the compute and the data science become a very much integral part of the while trying to discover a lot of the things that is happening inside the cell or inside the human physiology in general. Yeah.
Thanks so much for sharing that, right? And it's interesting because data has applications almost in all the fields today that they exist today. And I think your experience specifically in biology and the kind of questions you shared, that why X is happening versus Y. I think those are the questions that the students are also looking to answer, and really that is something which will ignite their curiosity. So I'm very excited for that. And I think another question, I think, as a follow-up, Professor Rintu, is that while we're sharing a lot about, the interdisciplinary aspects of biology and data science, but we had to only look at data science and what is happening as an extension in machine learning and artificial intelligence, data being a building block of it. What do you think? Like, why should high schoolers who are going to enter the workforce, probably 5 or 7 years later, why should high schoolers think about learning this, sort of, I think learning is a wrong word, but practicing this subject, like really tinkering with data and practicing the subject? Why do you think it's important for high schoolers to do that? What's your opinion on that?
So I think today's day, as the advancement in technology is happening, especially with the computation and the how language models like chat GPTs and all those, when we typically use those, we can solve a lot of the problems if you are an expert or domain expert in the field. But for a high schooler point of view, what I feel like, training them the foundation. I think foundation when it comes to the data science, it is typically to do with the doing very simple numerical operations, like what a high schooler will do, making those operations with computer, and with like fundamentals of very simple matrix multiplication to start with. I think those components should be threaded across, so that tomorrow when they are actually getting exposed to maybe a post their class 12, they exactly know that how much the domain expertise is relevant in today's day, despite we having those chat GPT like systems where it gives a very generic what do you call it, or whatever the information that is available in the in the internet, that will be available. But as you are going more deeper into the asking very difficult questions, those systems breaks. And I think that is what is our motivation, is that trying to train the, or the maybe induce the thinking process to them, that how the data science, machine learning, or AI has a very foundational strong building block of mathematics, for example. I think that is the emphasis that we will bring into the the students also, and that is the way it should be. Then they will can understand if the chat GPT is giving some wrong information, because it will provide some predictions, and predictions can be wrong. At the human judgment at the level of students, they should able to change those things and see, oh, this is not correct, this is wrong. I think that is what I think make us human as more intelligent than as systems like chat GPT and all those. Yeah.
Oh, and I think my takeaway from what you've said is that right now the focus for anybody who is interested in the field of data science, any high school student, should be on building their foundations right, so that tomorrow, if you know whether language changes or whether the tool changes or whether there are other advancements, if the foundations are right, they will be able to apply that even with the changes.
Correct,
As
correct. And they will able to understand. And I think they will able to, see why it is behaving. I think that is more to do with today's generation of, computer science people also started looking into why that is behaving like that, and how we can change the behaviors. There are a lot of ethics and other lot of components are there, but yeah, that is the first foundation is the key. Yeah.
Sure. Thanks so much. And I think, Professor Bango, to you now, like when I sort of read about, how we are probably close to finding life on Mars, I don't know how close, or maybe, even understanding that how, reading about how, astronauts actually got stuck in space for so long, but they still survived and they came back. I think those are almost miracles in my head, and I think I would want to understand, that what is happening in the field of astrophysics that can be taken forward, for a high schooler if they get into this field of astrophysics, they are interested in it. Why should they sort of focus on it today to be prepared for the future workforce? I think if you could give your 2 cents on that.
I would say that astrophysics is an area which is curiosity driven, right? So you're looking at things happening outside of your terrestrial boundaries. It is not as though anything that you discover or learn from there is going to directly impact your life today, right? But it has lessons in the understanding of a very deep philosophical quest as to how did everything that we see around us come about? How did all these elements around us originate? How did these planets, stars come about? How did we come about? Right? So most of astrophysical research is actually driven by this quest. So if you look at the NASA programs, they have given it a name. It's called the Origins Project. So we are looking at origins of everything, going back to the origin of the universe. So this is, as I said, a curiosity-driven endeavor. And I think humans are humans because they are curious. And that is what drives the interest in astrophysics. And there's billions and billions of dollars of investment that are coming into astrophysics today because of this. And of course, once we learn something, humans are always good to putting them to use. So now people will think of maybe going to the moon and mine it, going to Mars and mine it for our own benefit. Now, I'm not saying that I would advocate that, but that's a byproduct of this knowledge. Always when we create fundamental knowledge, that then gets adopted into technology and adopted into our way of life in some sense. So you talked about life. I don't know how close we are to finding life until we find it, right? So this is always a quest for the future, but one is trying. That's one of the endeavors in astronomy and astrophysics. But we're also trying to find and isolate places where life could possibly exist. So you shortlist those areas and look more deeply in those directions. To do that, you have to observe a huge number of objects. So this is an exercise in outlier detection. You have a very large data set, and then you find those which specifically meet certain criteria. And this is something we will talk about in this course, as to how do we decide what is a habitable planet and how do we find them, right? And we will actually go through some of the data sets that have been collected by space missions about planets. There are more than 5,000 planets outside the solar system that have been found, and they continue to be found. And then it's an exercise in classification in multiple parameters, and then find what may be a good target for looking for life. So yes, that's one direction where, for example, even high schoolers can get involved. Lot of astronomy, there are many branches of astronomy have floated this idea of citizen science. So there are curated data sets made available, and anyone, starting from layman to high schoolers to anyone who is interested, can get involved in doing small projects with this data. Projects are also listed. Some training is given if you volunteer and if you register. We will introduce these students to some of those data sets, some of those directions, including the data of stars and planets, with which they can pursue their own interests and contribute to the advancement of science itself. And in fact, citizen science has produced many interesting discoveries by people who are not professional scientists. At least two most famous papers out of citizen science are done by high schoolers. A completely new type of galaxies are found by high schoolers. The galaxies are called green peas because they look like green peas. So, but the high schoolers found them in citizen science data. So I think there's a lot of interesting stuff if high schooler can get involved in, if they have the inclination and the drive. And after all, you're going to find something new. That is not everyone is going to find something new, but it's the combined effort of many people that sometimes leads to some spectacular discoveries. And astronomy, as I said, is the study of such vast array of objects. There's so much to find out there. In one of my lectures some time ago, I was trying to enumerate, okay, so how much would I quantify as the astronomy discovery space, right? So in any sub area that you look at, the amount of information that you have gained as a fraction of what actually is likely to exist is never more than 0.1%. So for every kind of phenomena we know today, there are 10,000 times more phenomena, 1,000 to 10,000 times more phenomena to be found. And that can be found only through this technological advancement, collecting more data and intelligently going through them. And that is something that we are going to introduce the students to.
Thank you. And I think thanks so much for almost like taking us through the journey of the course, through different aspects, through different segments you will cover in the course. And, I think what I understand a lot from this is that how astrophysics is a continuous quest and how billions of dollars are being invested in it. So it's definitely a field of the future. Which takes me to my next question, and very, very briefly and specifically, if I had to ask you, what are, let's say, the top 3 careers for somebody who's interested in getting into the field of astrophysics? What are the top 3 future careers that, a student who enters astrophysics can pursue and should sort of strive to pursue? And I know it's hard to sort of put it in the top 3 bracket, but if you could sort of broadly talk about that.
Yes, because the study of astrophysics acquaints you to multiple kinds of skills, right? So what I see that is students that have finished astrophysics research, for example, where they have ended up. A good fraction stay in the academics, become researchers and educators. But a substantial fraction go into the industry because astrophysics research involves a lot of computing techniques, and there's a big demand in the industry now today for people who are trained in those techniques. Then there are also people who, with this knowledge, become basically thinkers and influencers of basically in the community, community workers who utilize the realization, one realization that you will have when you have gone a deep understanding of astronomy is how insignificant we are in the universe, right? And as soon as you put that perspective, our everyday conflicts almost become totally meaningless, right? So we are so self-centered that we get into these conflicts. But when you really look at it in the universe's perspective, this is totally meaningless. So once you have that realization, you can approach life in a different way, and you can also transmit that thought. And there's a significant number of people who have actually gone in that direction, including those who have done astronomy and have become astronauts, in fact, have gone and visited. You're talking about Sunita Williams and others who got stuck in space, but there are, over time, there are many such people who have actually been to space. And everybody, without exception, says that the feeling, overwhelming feeling that they get when they are up in space is how fragile the Earth is. The small object in vast spans of space. So I think that's a very profound thought, and that also changes it.
Oh, thank you. And I know our attendees have been asking questions and posting questions in chat, but please do give us some more time, maybe another 10 minutes before we get to your questions one by one. Thank you for your patience. And I think, Professor Rintu, my question to you is that, when we talk about careers in data specifically, I don't think it can be bucketed into any one career. But, I often read about the importance of, let's say, AI and ethics, and how the industry actually today demands people who are data science and AI sort of experts, or they understand the field very well, but also at the same time are able to put an ethics lens to it, are able to manage the ethics lens, are able to sort of execute that on a day-to-day platform, digital platform level. So, keeping those things in mind, if you had to talk about, what are some future careers that you see growing into the field of data science, that yes, tomorrow probably somebody who knows X language will not matter, but somebody who's able to sort of, do this with the intelligence or surpass the intelligence in certain manner will matter. So what are, I think, while there is a future perspective to careers in data science, but there are also some future careers that will grow in this field. If you could talk about that, please.
Okay. So I think I will first, connect one of the questions that one student has been asking, and also relate that one effectively. So the data science and machine learning and AI has been like, present everywhere. Like, if it is not about today, I think it has been there since ages, and only the point is that, the people have recognized the relevance and the importance of data science and machine learning and AI in general, is that when you have a lot of information in the form of data, you require, methodologies, or algorithms, very specifically in computer science language, is that you require automatic algorithm systems to find patterns. That is very, very important. That is the whole crux of data science and machine learning or AI. And when we come about the domains that are utilized, that can be utilized in economics, that can be utilized in, in any manufacturing industry, or retail industry, or in fact in biology, or in fact physics, chemistry, it is like endless, okay, to point it out. But most importantly, when we talk about the future, like the new kind of areas that's coming up, like as you mentioned about the legal aspects of or the regulatory aspects of those systems, not data science or machine learning, but this systems who are unpredictable. For example, the language models and all those stuff, and why we require those what do you call as domain to be uh, much controlled or governed, because we have very less people in those areas, or in fact legal people who understand data science, machine learning and AI, or data science people who understand machine learning and AI but has a professional education in maybe in legal. And I think that's where typically, in fact, our role in at Ashoka, we have a very strong emphasis on that, how a student actually get exposed to and also get into this interdisciplinary aspects of courses, and also the minor, major, whatever the programs we have. I think the advantage that we provide also is that because we understand that the disciplines that we are today in, and in fact future disciplines which are more multidisciplinary in nature, or and the topic which we are touching upon, it is more of like a transdisciplinary in nature, where you have to expect have a understanding of human behavior, when it comes to, for example, medical devices or software as a medical devices. There, it is not only the doctors that is making decisions. That time you have to have a people who are actually making those devices, medical devices, where they will be typically the engineers. And then you will have a computer science people who are writing codes, whatever the device is actually producing some signals, convert them into a more less noisy and more in the signal that whatever we are expecting from the instrument. And there will be some nurse will be there who will be using that system in the hospital setting. And if you look at the whole across, there is a data generation happening, there is a machine learning algorithm that is inside the device itself, and there are some decisions which need to be made from a perspective of a the doctor, where he will be using that software at the software and the hardware at the same time. And those legalities and the regulations are becomes a very critical part, and that is the future. Typically it is like, it is not about like machine learning you can do in a IPython notebooks and all, learning purpose, everything is there. But when it comes to real world deployment of those systems, I think it is a huge area, and it is not only medical domain. I think in legal and wherever there is a huge amount of data, and we are not only having a issues of like we are, as a human, we are not so much capable of handling that enormous amount of data, which might be very domain specific. And that's where the if somebody is very much in the intersection of legal documents, they understand at the same time, they also understand the machine learning or the AI systems, they can really become those frontiers, or in fact the frontier professionals, which will be very very much important, yeah, in any discipline typically. Yeah.
Sure, thank you so much. Because I think two aspects I think that you highlighted here definitely is law and healthcare as two fields which are very sort of which are definitely interdisciplinary with data, but also something which will be the need of the hour tomorrow. I think in future these are the fields that we will need professionals who have knowledge of these two interdisciplinary fields and are able to apply that to different segments. So thanks so much, Professor Rindut. I think that gives a very clear lens to our students. And I think now I'll dive into our program, our courses. And I think my question to you, Professor Dipankar, is that if you could talk about, I know you've already spoken about some aspects of what the course will cover. But if you could talk about, sort of what excites you to teach this course, or what is that one core outcome that students you think will take away from this course?
Well, as the title suggests,
Stars,
the
less than us.
the purpose of the course is to highlight the central role of stars in everything that we see, and in the origin of life as well. So we want to introduce the entire life history of the universe, as we know, from the Big Bang to today, and how most of the things that we see today has been shaped by multiple life cycles of stars. So we are going to introduce what a life cycle of star means, how does a star get born, how does it die, what does it produce as a byproduct, and how does that byproduct then shape the evolution of the universe later on. So that's the astrophysics aspect of it. And to do so, there is some notion going around that science is only now beginning to use data, but that's not true. Science has always been about data. What is happening today is the volume of the data has become so much that you need additional techniques to fully digest them. So, and astronomy is a very old subject. If people ask me as to about big data, I have often been asked to talk about big data in astronomy. So I start with the example of Kepler, who took 26 years of data collected by Tycho Brahe and manually analyzed all of this and came up with the ellipticity of the orbit of Mars. It was a phenomenal discovery, completely manual, with such high volumes of data, just calculating and computing on pieces of paper. So that is as big an achievement in big data in those scales as a new data set, modern data set is going to give us today. So we have just scaled it up. So everything that we do is based on data. All astronomy discoveries, astronomy analysis is based on data. So we are going to introduce, I mentioned this earlier, where is this data available? Now we are collecting more and more and more data every day. But this data, for the reason that we need to exploit it well, is made open to people. But most people may not know that there is such data sitting around. So we will introduce people to how to access this data, what this data means, and how you can draw scientific inference based on this data, right? And then connect to all these points that I mentioned, starting from the starting of the universe to today, how this entire progression of evolution has happened. It's all there in the data that we collect. And how do we extract this information from this data? So students are actually going to do this as projects. So they are going to take pieces of data and look for these signatures and come to this conclusion.
Sure, thank you. And I think it's interesting because the students will actually get to wear the hat of an astrophysicist and apply the knowledge using data. I think a lot of times one thing is knowing the knowledge, one thing is knowing about stars, their composition, planets, how the universe came in. But the other sort of aspect, and I think the bigger sort of challenge is that to apply that knowledge, and especially using data. So I think that this course on Stardust and us will definitely challenge our students to do that and get them on a different journey completely. And I think, Professor Jintu, if you could talk about your course, Applied Data Science with ML and AI. And I am very interested in knowing the more about applied, more about ML, more about AI also, that how all of these three things will come in through data science. What is exciting you the most about the course? Not just the projects. Of course, I know you're doing a lot of interesting projects on using data in economics, healthcare, climate change, but also looking at the extended opportunity some top students can get to work with the center at Ashoka, and work on projects almost like mini internships that they can do. So if you could talk a little bit about, really what is the opportunity here for students and what is the core outcome that students will get out of the course?
So I think first I will go with the last one, later question. So then I will come to the second part, which is the opportunity that is there. So at the first place, what the applied data science course actually typically maintains that we will go with two approaches. One is like, hypothesis driven, and what is the, hypothesis free one, which is more like a data driven approach that is there. And before we go to data driven approach, I think first and foremost, what the students will get out of the course is primarily, that scientific journey start as, Professor Dipankar already mentioned, that scientific journey always start with a question and the curiosity. Then, based on that hypothesis or the curiosityness, you start collecting data, and collecting data can be like, today's day we can do using a microscope, which is like see inside the system, or outside with a telescope. There are various way, or with a naked eye you can count some, physical systems. And all of this is led to something which is very common across disciplines, is that there are different kind of data types that we have universally have a, component. One can come with a simple, like, numbers, which is we will discuss about them, what are the different kinds of data that you get from. For example, we will talk about MRI images, which is more of like a 3D volumetric images, from a very much, microscopies images, which is are very much like, one dimensional, like 2D. And but you can have a, multi-dimensional aspect to that also. And once we understand the first block, that what different kind of data that can be present, whether it is a climate data, whether it is economics data, then students will not see them as a discipline specific data, but data in a matrix format. And I think once that understanding comes as a student, that this numbers whatever we are getting, that will go into a matrix, and simple matrix manipulations can give you, insights, which is fundamentally goes across disciplines. And I think that is the power that we will provide to them, that the confidence that, whenever they see a question or curiosity they develop, or somebody is having a big question with a lot of data, they will first try to understand what nature of data has been generated or collected. And using then the, the ML algorithms that exist, or statistical methods, for example, the foundational, so very simple univariate analysis, then multivariate analysis, then using machine learning algorithms, where depending on the question they are asking, or then going to more higher level, machine learning algorithm or advanced machine learning algorithm, where you have more conditionalization of the, data points. And that exactly what we want to take them across, is that first make them confident that, given a question, there is a data will come, and what is that data, first understand. Why we are stressing on this fundamentals? Because depending on the data type, you use appropriate algorithms. You cannot use an algorithm if you don't understand the how the data is. For example, if you have a lot of, I don't want to put the specific term, but when you have more zeros, like, a lot of zeros in your matrix, then you use very specific algorithm which is only for that specific type of matrices. And those understanding, once those students get, I think that is what something which is, a chat GPT system will be very difficult to actually answer. And there the domain expertise also come, method exploration also come. Then they start thinking about not only, the troubles that is there in the existing algorithms, but they will have that, curiosity that, can I develop new algorithms itself, whether it is a X, Y, Z discipline, but can I develop something which is whatever the domain expert is asking the question, can I provide solutions? And that is exactly that leads to the second part of the story, which is to do with, like, we have in Ashoka, I think more than 20 centers we have here, where we have a all different department actually comes together, and we have centers which are more interdisciplinary and multidisciplinary. Those people who are interested in very specific problem statement, maybe in health, maybe in economics, or maybe any climatic conditions or problems they are interested in. It can come from satellite images, it can come from public health data set, whatever they are want to ask, they will get an opportunity to, have a one-on-one discussion with the, the faculties here. And definitely they will get a chance to, go deeper into the, after their foundations are, very strong. Yeah. You are mute.
Aditi, you're on mute.
I'm so sorry. I think it really highlights that, getting the fundamentals right is actually opening the door to for these students to get into much advanced stages of data science, ML, and AI. And also, I think as an opportunity to even solve a problem with data at the university, at Ashoka University, work with you on such a project, I think that's something that the students will really get like a very sort of detailed experience out of that. So thanks so much, I think, for this quick fireside chat. Not so quick, but thank you so much for such a nice and detailed fireside chat. I think one of the things that Professor Dipankar you said really touched me today to say that how insignificant we are as humans when we get into the field of astrophysics because our daily conflicts don't matter and our daily challenges don't matter. Things that seem so big, we realize that how we are fragile and the earth is also fragile. So thanks so much for sharing such a beautiful thing. And on that note, I would like to actually end the fireside chat now and open it up for questions. We do have some questions in chat as well, so you can take a look at it. But I think we've covered a lot of answers to these questions. So I would like to invite our attendees. You will be able to unmute yourself and ask any questions you want. If you have any questions regarding the courses of Stardust and us, and regarding the courses or course on applied data science with ML and AI, please do ask that. If you have any questions related to careers or related to opportunities in the field of data science or interdisciplinary field of data science and biology, or in the field of astrophysics and data science as well, please do ask those questions. But if you have any other questions regarding the program, regarding Ashoka University, how the university functions or what is the kind of programs available, what is the fee, all of that will be taken up later by me and my team. So please, if you have any questions for our professors, please feel free to unmute yourself and ask now. Any questions that you feel you've not been given answers to, please feel free to ask that. We do have a question, I think, Professor Dipankar, in chat by Kamal Kar, who's asking that if a student is interested in theoretical physics, would they benefit from the Horizons program on astrophysics? And if they would benefit, how would they benefit? If you could answer that, maybe to begin with.
I think what we're going to discuss is the theoretical framework on which the stellar evolution theory is based. We are going to be descriptive. We are not equipped to describe the nitty-gritties of the theory at the school level, but we will introduce them to the conceptual pathways, which can then be developed into theories. As they get more trained, they'll be able to do theoretical analysis. But by and large, the stellar evolution is based, the understanding of stellar evolution is based strongly on theory. It's actually a branch of theoretical physics. But nothing in science is all theoretical. So we have observational data, observational viewpoints, which connect to validate the theory. After all, the theory is to explain something. So what is that something? So I do not distinguish so much between fully theoretical work and observational work or experimental work, because science cannot progress without both going hand in hand. Because we are really looking for explaining phenomena in nature. If we haven't observed any phenomena to explain, there is no real guidance for theory. So there are two sides of the same coin, but there will be enough input for a theoretical physicist to think about from the concepts discussed in the course.
Thank you. I think, Kamalkar, I hope Professor was able to answer your question. If you have any other questions, please feel free to unmute yourself and ask as well. We do have a question from Meher, Professor Rintu, for you. As a 16-year-old going into 12th grade, how do I introduce myself to data science? specifically data science with economics or data science with AI? If you could answer that.
So I think data science in general, as I was telling, it is very important to have the understanding of, for example, the basic foundation of mathematics for doing machine learning. And once that is there, I think it is not a problem at all to do a specifically interest on data science in economics, or in fact in data science in AI. I think both is definitely can be possible. And there are resources which are there, which we will be providing, which will make their learning pathway more accessible in very specifically on the data science part of it. Then the domain specific knowledge, you will require some amount of understanding for that one. And once that is there, both the foundation of the data science and the domain expertise, I think that should be easy to start with. Yeah.
Thank you for sharing that. We also have a question from Neeraj at the beginning, where he has mentioned that would an undergrad in data and biology, like an interdisciplinary, probably as I understand, at Ashoka University count as a pre-med track in the US? And I know that's a very specific question, Professor Intu, but maybe if we have
Yeah,
any.
so I think for the pre-med track, I think there are a lot of already. So we have a past record of, like, I've been here at Ashoka for almost 3 years. So I've been training those that kind of the students who come with, for example, major in CS, then minor in biology, or the other way around, which is the major in biology and minor in CS. And they typically land up into those programs, which is it makes them very unique in the first place. Let me be very honest with that. And they go into very prominent, or in fact, for example, one of the students who was having a major in biology and minor in CS, she went to CMU last year. And most importantly, what her work involved with is to do with systems biology, and a little bit of digital pathology, which is to do in high resolution microscope images. And she used machine learning algorithm and deep learning algorithms to quantify what different kind of cells, immune tumor interactions that is happening, or and in triple negative breast cancers, how those if you give the therapy, is there any improvement in the ecosystem of the those tumor microenvironment itself. And I think that is the one of the best part that we have, not only in biology, but if you go with, like, for example, we have programs in CS econ, or econ CS, or CS entrepreneurship. And there are a lot of the mix and match is there, depending on the students interest. And I think that is a flexibility that also we have the programs accordingly. It is more interdisciplinary in nature. And definitely for the specifically to the nearest question, I think yes, it is possible. So once you do an undergrad in biology major, then CS minor. And in fact, I think one more person I think asked about is there any program in data science. I think we are so data science is the, like, the additional component than the domain expertise. So there are programs that we already have which have a component of data science along with the specific subjects. Yeah.
Thank you. Any other questions? Please do share that with us. We'll actually, Arshi, I think your hand is raised. So
Yeah, Aditi, I wanted us to introduce Isha as well, so that she can walk us through her journey of being a UG student at Ashoka University.
Sure. Yes. Isha, please do come in. Thanks so much for joining us today. You have been a student at Ashoka University. So I think my question to you is to really sort of understand what's been your journey, how has your experience been at Ashoka campus, and also if you could talk about your work in astrophysics and what have you done in the field.
Right. Thank you so much, Aditi. Can you hear me?
Yes.
Okay. So I came into physics at Ashoka, not really decided on, what part of physics I was interested in. And through the courses and through projects that I got an opportunity to take, I was able to find that I was really interested in astrophysics. In fact, one of my first projects was with Professor Dipankar in the astronomy lab, where we were setting up a radio telescope and trying to sort of use that to answer certain questions to see how to collect data using that telescope on campus, which was a really unique kind of project to get an opportunity to work on. And so coming to what I'm doing right now, I'm doing a fourth year thesis with Professor Dipankar, and I'm using data from an Indian X-ray satellite, and using that to study a low mass X-ray binary system, which is a system that has a black hole and a star in it, which I'm sure is, the kind of thing that that will be covered a lot more in the course. But it's been really nice doing physics and astrophysics in particular at Ashoka, because not only is there an opportunity to study the fundamentals of physics and astrophysics, but there's a lot of focus on learning the very necessary skills that you require for research, and a lot of focus on really understanding how to work with data and how to really get started with research at a very early stage.
Thank you. Thank you for sharing that. And thank you for even talking about your experience at the campus, about how you actually got into setting up a radio telescope with Professor Dibankar, and what sort of led to that in terms of your project and your work. So thanks so much for sharing that. So very quickly, if you don't have any questions, I would like to quickly share about the Horizons program with everyone before we close. So why Horizons program is unique at Ashoka is because it is deeply immersive, and we will be working in small cohorts. Batch size will be around 25 students. It is taught by leading global faculty and industry experts. You already met two of our leading global faculty today. Each course will have a very, very special feature of a capstone project, where you will actually create something, you'll actually do something, and you'll come out with a tangible outcome of it. For example, in the astrophysics course, you will work on real astronomical data, draw insights from it, and actually sort of uh, sort of recommend those insights for application in the field. And at the same time, in the data science course, you can choose actually 2-3 different tracks and 2-3 different fields, and cull out data in those fields, and sort of draw insights to make recommendation. And these fields can be around economics, it can be around healthcare, and it can be around climate change. We have some high industry standards. As you can see, the course rating is 4.5 out of 5 for all our courses, for most of our courses for the entire program, and we have 95% completion rate. Um, we also have, these are university certified. So of course, you will get certification from Ashoka University, and they're only on weekends for 18 hours between 17th May to 14th June. Some top students also have opportunities for internships, research opportunities, mentorships, letter of recommendations, and other rewards and recognitions. Because I think somebody in chat also asked about internship opportunities at Ashoka University. I would like to tell you that if you sign up for a Horizons course, if you enroll, and if you perform well, top students will have a chance to this. And of course, I think this is one of the major sort of takeaways, one of the major advantages of the Horizons program is that you will be able to strengthen your own knowledge and your own profile to prepare early for college and really sort of get an edge over your college applications. So thank you so much for joining us today. Here is our course catalog. It is also available on our website. If you go to Horizons Achievers Program, Ashoka University website, you'll be able to see all our courses, and you'll be able to get a detail of all our courses and know when to apply. The deadline for our course, for the application, the early application deadline is 6th April. So please do enroll as soon as you want to and as soon as you can. You can also scan our QR code. You can write to us as horizons at ashoka.edu.in for any questions. Please do tell us how your experience in the poll I'll be sharing. It'll be great to know your interest. It'll be great to know your experience of the webinar. And if you have any further questions, please do feel you're free to stick around and ask any questions that you want to. So you will see a poll on your screen. It'll be great if you can answer that very quickly. In the meantime, I would request our professors, thank you so much for being with us today. Thank you so much for answering our questions. I know we are over time. So thank you so much. Please do feel free to drop off in case you have to. We will reach out
Thank
to
you.
students, ask us any questions. Thank you. Thank you so
Okay,
much.
bye-bye. Take care,
Bye-bye.
guys.
Thank you.
Thank
Thank
you,
you.
Professor Dipankar. Thank you, Professor Ritu.
Bye.
Do we have any questions with respect to our program, our courses, our app deadlines? Okay. Thank you so much. Thank you, Aditi, for this amazing session.
Thank you so much. Please do email us if you have any other queries. We will be closing the webinar now. Thank you.